Okay, so our first short little exercise from today's Power Up is to write 12 and 1/2, to rewrite this 12 and 1/2 as a radical. Okay, so what does it mean to rewrite when you have a number and you have an exponent that is a fraction? What does it mean to rewrite that as a radical? Well, a radical is anything that's under a symbol that looks like this. In this case, actually, since it's the 1/2 power, the 1/2 power is the square root. Okay? Very important thing to know is that this power, this 1/2 power, this is the thing, the most basic of our fractional exponents, and it just gives you the square root of 12. Of course, what we're going to do, we're not just going to leave it as the square root of 12. We're going to see if we can reduce this at all. So the square root of 12 is the same as the square root of 3 times 4, right? 3 times 4 is 12. Okay? So what we're going to do is we're going to make the square root of 3 times 4, that's the same as the square root of 3 times the square root of 4. And we can see that we can take actually that 4. We know that the square root of 4 is 2. So we can end up with saying that this is 2 square root of 3. And that's what we're going to do, 2 square root of 3. So that's our final answer for that one. Okay. Then we're going to go ahead and we're going to look at this thing, number 2. How are we going to rewrite the cube root of 17 as an exponent? Okay, well, I just told you just now that when you see this symbol here, okay, that's a radical symbol, and I just told you that that is equivalent to a fractional exponent. In this case, we're not going to be able to, reduce that or anything like that because 17 is a prime number. So we're going to take the 17 and we're going to raise it to a power, and we're going to raise it to a fractional power. And in this case, we're looking at this 3 right here, and we're going to say, well, since 3 is the index of this particular radical, we know that this is 17 to the 1/3 power. 17 to the 1/3 power. That is what this symbol means right here, and that is the answer to this one. Okay, great. Next, we need to simplify 6i multiplied by 5 minus 3i. And this is something that we reviewed right before the break, but in case you've forgotten already, one of the things that we know is that the symbol I represents the square root of -1. Therefore, when we square I, that is the same as just -1. So I is the square root of -1, and I squared is -1. Okay? So we're going to use both of those things as we're going to go ahead and we're going to distribute this 6i into the set of parentheses, just like we would distribute any number into any binomial. And so we're going to say that 6i times 5 is 30i. Okay? And then we're going to say that 6i times -3i is -18i squared. So minus 18i squared. But of course, we know that I squared is equal to -1. Okay, I squared equals -1. So we're going to go ahead and we're going to say that this is the same as 30i minus 18 times -1. Well, -1 times -18 is positive 18. So you're going to end up with 30i plus 18. And then if you recall, we're going to have to switch places because anytime we have a complex number, we put the real part of that number first. So it's going to be 18. And then we put the imaginary part, 18 plus 30i. Okay, great. Moving along. This next one is going to be also pretty straightforward. We're going to continue to remember that I is equal to the square root of -1 and that I squared is equal to -1. Because when you square a square root, when you square a square root, you get rid of the square root. Okay, cool. So what we're going to do now is we're going to go ahead and we're going to do this 2 minus 3i times the 5 plus 8i, and this is going to be like foiling, right? 2 times 5, then 2 times 8i, then negative 3i times 5, and then negative 3i times 8i. So let's see. We've got 2 times 5, which is 10. Then we have 2 times 8i, which is 16i. Then we have negative 3i times 5, which is negative 15i. And then we have negative 3i times 8, which is negative 24. And what happens when we do the I times the I? Negative 24i squared. Okay? So 2 times 5 is 10. 2 times 8i is 16i. Negative 3i times 5 is negative 15i. And negative 3i times 8i is negative 24i squared. Okay, now, the next thing we do is we combine these two like terms, and we get 10 plus I, right? 16 minus 15 is 1. So just regular old I. And then this is going to be minus 24 times, okay? I squared is negative 1, right? So it's going to be negative 24 times negative 1. And we'll get 10 plus I plus 24. And we're going to add this 24 to this 10, and we're going to end up with 34 plus I. Okay? And then the last thing we're going to do is we're going to solve x squared minus 14x plus 49 is equal to 0. We're going to solve that by factoring. And when I factor a trinomial, I end up opening my two things, setting this equal to 0. Since there is no coefficient here that implies that there's a coefficient of 1, so you start out with an x here and an x here. Since this is minus, but this is plus, we know this plus means that my signs are going to match, and this minus indicates that they're both going to be minus. So I'm going to put a minus here and a minus here. But there's one more thing that exists here, which is if I look closely at this trinomial, it's got a special property. We're going to talk about that in a second. In the meantime, we need two numbers that multiply to give us 49 and add to give us negative 14, right? So we need, so we're going to say, okay, so I've got 1 and 49. Remember they're both negatives, okay? They're both negatives. So I need negative 1 times negative 49. Well, that doesn't add to give me negative 14, so that's not going to work. It's going to give me negative 50. It doesn't divide by 2. Let's see, what else? Oh, wait a minute. 49 is 7 squared, right? Which means that I could square negative 7 to get 49 as well, right? Negative 7 times negative 7 is equal to 49. And negative 7 plus negative 7 equals negative 14. So it's going to be x minus 7 times x minus 7 equals 0. And then normally you would split this into two different equations, right? But I don't have to do that because they're the same. So all I really have to do is x minus 7 equals 0, right? Okay, so x minus 7 equals 0. So then I just add my 7 to both sides, and I get that x equals 7. But hold your horses. Look at this thing right here. That says x minus 7 times x minus 7. That means this is x minus 7 squared equals 0. And I just wanted to point that out because this right here, this right, this right here is a perfect square trinomial, kind of like what we were talking about last week. Alrighty then.